University Synchronized, belongs to the physics department. I have to deal about the properties of a matter. These are the content of the properties of matter. Elasticity, stress strain diagram uses torsional stress and deformation, twisting couple, torsional pendulum, theory and experiment, bending of beams, bending moment, cantilever, theory and experiment, uniform and non-uniform bending, theory and experiment, and I-shaped gutter. This will cover under the properties of matter. Now we have to see about the basic definition. The external force acting on a body on account of the which its size or shape or both change is said to be a deforming force. That is, the external force acting on your body on account of which its size or shape or both change is said to be deforming force. Next, you have to see about the restoring force. A force which restores the size and shape of the body when deformation forces are removed, that is known as restoring. That is, restore means that is store is restored. For it is F is equal to minus kx. The negative sign indicates the opposing the force. Next, you have to see about the rigid body. Rigid body is nothing but a body whose shape and size cannot be changed over the large applied forces called rigid body. There is no perfect rigid body in nature. Example, you have to say about stone. Stone is considered as a rigid body. Here, when we apply large amount of force, body shape and size cannot be changed. That body is said to be rigid body. Then next you have to say about the elasticity. The property of a body by the virtue of it, which it regain its original size and shape immediately after the deforming forces are removed is called elasticity. Elasticity is a molecular phenomenon. It is because of cohesive forces. That is, the body regain its original size and shape immediately after the deforming forces are removed. That is known as elasticity. What is meant by elastic body? Next you see about the elastic body. Elastic body is one that returns to its original shape after a deformation. For example, if you use a rubber band, if you stretch the rubber band at both ends by your hand, the rubber band expands upon applying the forces at the both ends of the band. When we release or when we release the rubber band regain its original shape. So the rubber band is considered as an elastic body. That is, elastic body is one that return to its original shape after a deformation. Next, you see about the plastic body. An inelastic body is one that does not return to its original shape after a deformation. That is said to be a plastic body. An inelastic body is one that does not return to its original shape after a deformation is said to be a plastic body. Example, clay, mud, wax, lead, chewing gum, butter, wax are said to be a plastic body. Elastic or inelastic collision. Next is about the collision, whether the collision is elastic or whether it is inelastic. What do you mean by elastic collision? Elastic collision loses no energy. The deformation or collision is fully restored. But in inelastic collision, energy is lost and the deformation may be permanent. In elastic collision, there is no loss of energy taken place. But in deformation or collision is here deformation of this elastic collision is fully restored. In inelastic collision, energy is lost and the deformation may be permanent. Next is about the elastic spring, how the spring behaves elastically. A spring is an example for an elastic body that can be deformed by stretching. Here, one end of the spring is tied one end and another end is that is weight is supported at the other end. When we give the force at one end, automatically the spring relaxes elastically to another position. and the weight is removed, the spring will be retain its original length. That is, the here some forces will be act. Such force is to be restoring force. Okay. The restoring force F acts in the direction opposite the displacement of the oscillating body. Here X is the direction of the force by applied because of uh, because of the weight order at the one end. So there will be displacement from its original position. Therefore, there will be some force will be opposes. That force is said to be restoring force opposite to the direction of the force. So we have to indicate with the negative sign. F is equal to minus kx. Next, we have to say about the stress and strain. Stress is nothing but it refers to the cause of a deformation. Stress refers to the cause of a deformation. Strain refers to the effect of deformation. Stress is only the cause, but strain is the effect. So there will be difference between the cause and the effect. First, you have to say about the stress. The same diagram which is expressed in the restoring force. Here, the stress is the force, the strain is the elongation. The same, the spring, elastic spring is tied at one end, another end is given with the weight. When the weight is added, so that there will be the spring will be expanded elastically, there will be a downward force will be act. At the same time, there will be a upward force is also works. The downward force causes the displacement through a distance x. Here the stress is the force and the strain is the elongation. The stress is nothing but the force given and strain is the elongation. So stress is the cause and the strain is the effect. So from that we can explain and clearly understood the stress and strain. What is the difference between stress and strain? Stress is nothing but a restoring force developed per unit area of cross section of the deformed body is called stress. A restoring force developed per unit area of cross section of the deformed body is called stress. That is sigma is equal to F by A. F by A force acting per unit area. Unit is Newton per meter square or Pascal. This is the stress. Stress is nothing but we already defined that it is a cause of the deformation. Strain is refers to the effect of deformation. Stress is refers to the cause of a deformation. Strain is refers to the effect of the deformation. Next, you have to deal about the stress. What are the types of stress? There are three different types of stresses are there. One is normal stress. Another one is shear stress. Third one is bulk stress. These are the three different types of stresses are there. One is normal stress, another one is shear stress or otherwise known as tangential stress. Third one is bulk stress or volume stress. Normal stress is nothing but a force acting perpendicular to the surface area. This diagram, this is the plane surface and the force is acting 90° to the area. It is said to be a normal stress. Normal means the angle between is 90°. Shear stress is nothing but or tangential stress. Force acts parallel to the area. Force acting parallel to the area is said to be a tangential stress or shear stress. Bulk stress. Force acting normally on all the faces. It's said to be bulk stress or volume stress. These are the three different types of stresses. Force acting perpendicular to a surface area is said to be a normal stress. Force acting parallel to the area is nothing but shear stress or tangential stress. Force acting normally on all the faces is said to be bulk stress. In second, shearing stress means the forces acting that is upward of the material, upward of the source, parallel, not perpendicular, parallel to the area. It is known as shear stress or tangential stress. Bulk stress or volume stress are forces will be act on normally for all the faces of the material. That is known as a bulk stress or volume stress. Uh, these are the normal types of the stress, normal ones, shearing stress and bulk stress. Next you have to see about types of tangential stress. The tangential stress is further divided into two types. One is tensile stress and another one is compressive stress. In tensile stress is occurred when equal and opposite forces are directed away from each other. That is, upward and downward forces are directed away, perpendicular, it is directed away from each other. That is known as tensile force. That is in the diagram, wire is hanged at one end, another end is given weight. Here the tensile stress will be produced based on that. That is, upward force is acting in one direction and downward force is acting in the opposite to the direction. Here the stress is developed, the stress is said to be tensile stress. And another one is compressive stress. Compressive stress is nothing but when equal and opposite forces are directed towards the same way, the upward and that is downward forces are facing toward each other, then there will be a compression will be taken place. So the stress will be developed. This stress is said to be compressive stress. So we can explain clearly the types of tangential stress. That is one is tensile stress, that is known as that is the equal and opposite forces directed away. The compressive stress means equal and opposite forces are directed towards each other. Strain. Deformation produced per unit magnitude is called strain. The ratio of change in dimension to its original dimension is known as strain. Strain is equal to change in dimension by original dimension. Dimension may be length or volume. Dimensional less quantity and has no unit. Here strain, that's already explained that it is a effect produced because of the cause happened by the stress. Here the deformation is produced per unit magnitude. Deformation because of the force applied, the deformation produced per unit magnitude is said to be a strain. And the strain is defined as the change in dimension to the original dimension. Here the both the quantities are same. So most probably the strain has no unit. It may be a length or volume, whatever may be. The unit for the strain will be no, yes, it has no unit. It is a dimensionless quantity. Then you have to explain about the types of strain. Strain is divided into three categories. One is longitudinal strain, volumetric strain, shear strain. Longitudinal strain, volumetric strain, shear strain. Longitudinal strain is defined as a deformed body is defined as the ratio of change in length of the body due to the deformation to its original length in the direction of the force. That is known as longitudinal strain. Longitudinal strain of a deformed body is defined as the ratio of change in length of the body to the deformation to its original length in the direction of the force. In this diagram, we have say that the same wire is hanged. One end of the wire is plugged into the right, and another end is plugged with the weight hanger. And the weight, when we put weight, when we add more weight, means the length of the wire will be expanded, and the change in the length will be noted as del L. From that, we have noticed the deformation. The deformation may be expressed in terms of longitudinal strain. Longitudinal strains can be understood by noting the change in length, how much the change in length will be. This original length might be the minus this expanded length. Then we get the change in length. When it is divided by the original length, we can get the longitudinal strain. Here, longitudinal strain has no unit because the uh, both the quantity in the numerator and the denominator will be a length, so it is dimensionless quantity. So the longitudinal strain, the unit is there is no unit for longitudinal strain. Then you have to stay another one is known as volumetric strain. Well, next you have to see about the volumetric strain. Here in the volumetric strain, we already discussed the volumetric stress. The bulk stress is nothing. The force is applied on the all the faces normal to it. It is defined as the volumetric strain of deformed body is defined as the ratio of change in volume of the body to the deformation to its original volume. Volume strain is equal to change in volume by original volume. Volume strain is equal to change in volume by original volume, del B by B. Next types of strain, and that is known as shearing strain or tangential strain. Shear strain is defined as the angular deformation produced on the body due to an application of the external tangential force. Shear strain theta of cubes equal to cc dash by bc. Here in a rectangular object, that is AB is fixed end and CD is the upper end. When we apply a force on the CD face, there will be change in the change in the shape of the bar at a rectangular slab. By applying the force at the upper surface, the D will be moved to D dash and C will be moved to C dash, so there will be angle will be produced. And this type of deformation is said to be a tangential strain or shearing strain. Here the strain will be calculated by the lateral displacement between two layers, that is C between C and C dash, or between D and D dash, and the perpendicular distance between the two lines, that is C to B or C dash to B or D dash to A or D to A. This how we can determine the value of the shearing strain or tangential strain. Elastic limit. Next, we have to see about the elastic limit. The elastic limit is the maximum stress a body can experience without becoming permanently deformed. That is known as elastic limit. The elastic limit is the maximum stress a body can experience without becoming permanently deformed. That is known as elastic limit. Here, the 2-meter wire is ordered. One end is fixed, another end is weighed with some weight hanger. When the weight is ordered means the length of the wire will be expanded. 2 meter, 2.5 meter, 3 meter, 3.5 meter. Likewise, the weight is added, and the more weight is added means the wire is subjected to broken. That is the limit for that particular, the elastic limit for the particular weight. If the stress exceeds the elastic limit, the final length will be longer than the original 2 meter. Final length will be longer than the original meter. For example, if the wire will be breaks at 3.5 meter means the original length will be a 2 meter and the wire breaks at 3.5 meter means then when the elastic limit will be for the particular wire, the length will be a 3.5 meter. This is the elastic limit for the particular wire. The ultimate strength. Ultimate strength, the final strength. The ultimate strength is the greatest stress a body can experience without breaking or rupturing. Ultimate strength will be determined without breaking the wire. It is the greatest stress. Greatest means more stress will be the body can experience. The same like that. First, you have to take a wire of 2 meter. One end is hanged, another end is that is weighed with some weight hanger. Weight is ordered so that the wire will be expanded. Before the string breaks, you have to note the ultimate strength of the wire. For example, 3.5 meters, it will be for if you increase the weight up to 4 means if the wire break means the ultimate strength of the body having the length is 3.5 meter. So the ultimate strength means the greatest stress a body can experience without breaking or rupturing. If the stress exceeds the, for example, if the stress exceeds the this ultimate length, the string breaks. For example, 3.5 meter is the ultimate strength of the wire, length of the wire. If it is the weight is ordered so that the length of the wire will exceeding 3.5 meter means the wire is subjected to break. This is the clear explanation about the ultimate strength. Then I have to explain about the Hooke's law. What do you mean by Hooke's law? Simply we say that Hooke's law states that nothing but the stress is directly proportional to strain. Likewise, you have to consider the elastic spring. One end is tied and another end is weighed with that is heat hanger. When a spring is stretched, there is a restoring force that is proportional to the displacement. F is equal to minus kx, where k is a spring constant and is a property of the spring. Hooke's law states that stress is directly proportional to strain. Stress is equal to E into strain. Modulus of velocity E is equal to stress by strain. When a spring is stretched, there is a restoring force that is proportional to the displacement. F is equal to minus kx, where k is the spring constant and is a property of the spring. Then next you have to see about the Poisson's ratio. Poisson ratio is nothing but here in the diagram, here is the cubical cylinder. The same that is D is the diameter, original diameter, and L is the length. Suppose the cubical cylinder is subjected to weight or subjected to expansion. Therefore, the original diameter will be changed into small that is diameter D, and the length will be expanded up to a small change in length will be actually L. So when a force is applied at one end, the deforming forces, because of the deforming forces, the diameter and the length of the cubical cylinder will be changed. Suppose if you want to find the Poisson ratio, you have to know that the Poisson ratio is nothing but lateral strain to the longitudinal strain. Lateral strain is nothing but change in radius by original radius, change in length by original length. This change in radius means nothing but small d by capital D, and the change in length is nothing but small l by capital L. Therefore, sigma is equal to beta by alpha. Therefore, sigma is equal to capital L into small d, small l into capital D. Poisson ratio, same that is strain. We already know that strain has no unit. Likewise, Poisson ratio also has a dimensional quantity and it has no unit. The theoretical limit shows that sigma is ranges between -1 to 0.5. Practical limit of sigma is equal to 0 to 0.5. If sigma is equal to 0.5, the substance is perfectly incompressible. If the Poisson ratio values exactly 0.5 means the substance is perfectly incompressible. Elastic deformation. This is the diagram which clearly explains how the deformation takes place. Elastic deformation, uniform plastic deformation, uniform plastic deformation, non-uniform plastic deformation, formation of microscopic defects. This is the clearly explain how the deformation takes place in the elastic body as well as plastic body. Elastic fatigue. Fatigue means the state of temporary loss of elastic nature due to continuous strain. Due to continuous strain. For example, uh, if you are using a material, using a weighing balance means, for example, if you are using a weighing balance for more than multiple times in a day, uh, after 1 year, if you are using the same weighing balance, the weighing balance does not show that correct reading. Why? Because of its the elastic nature will be lost. So this state is said to be an elastic fatigue. You have to see that what are the causes for the elastic fatigue. Elastic fatigue is already defined that the state of temporary loss of elastic nature due to continuous strain. The causes of elastic factors. A wire can be broken within the elastic limit. Within the elastic limit, if the wire is subject to elastic fatigue means the wire will said to be broken within the elastic limit. A wire can be cut into pieces. A wire can be cut into pieces without using instrument. A wire can be cut into pieces without using instrument. Without using instrument, a wire can be cut into pieces. Railway tracks and bridges are declared unsafe after long use. When the railway tracks and bridges are used for so many decades means, then the railway track and bridges will be considered as unsafe. Spring balance shows wrong readings. Spring balances using wrong readings after long use. This is the effects of the elastic fatigue. And next you have to see about what are the factors affecting the elasticity. These are the three, there is 1, 2, 3, 4, 5 factors, 5 major factors which are affecting the elasticity. First one is effect of cyclic stress. Effect of cyclic stress means we are giving force to the material for multiple times in a time. And the effect of temperature. Effect of temperature means based on the temperature, based on the heat exposed to the surface of a material, the elastic nature will be changed. And based on the materials, based on the impurities added to a material, so it may be affect the elasticity also. Based on the heating and cooling, the annealing, effect of annealing. Annealing is nothing but alternate heating and cooling causes annealing. Because of that behavior also, the elasticity factor will be affected. And the effect of nature of crystal, based on the pressure applied to a material, the crystalline nature behavior also affect the elasticity. Body loses its elastic property even within the elastic limit due to elastic fatigue. Apart from the elastic fatigue, some materials will have change in their property due to this factor. These are the factors affecting the elasticity. Modulus of elasticity. Provided that elastic limit is not exceeded, an elastic deformation is directly proportional to the magnitude of the applied force per unit area. Modulus of elasticity is equal to stress by strain. Based on strain, elastic modulus of solids are classified as linear strain results in Young's modulus, volume strain results in bulk modulus, shear strain results in rigidity modulus. Here in the modulus of elasticity, three different types of moduli of elasticity is understood. One is Young's modulus, another one is bulk modulus, and another one is rigidity modulus. The moduli of elasticity is nothing but ratio of stresses to the strain is nothing but moduli of elasticity. Here in the Young's modulus, it results it corresponds to the linear strain, and bulk modulus correspond to the volume strain, and rigidity modulus correspond to the shear strain. Young's modulus. Within the elastic limit, the ratio of the longitudinal stress to a longitudinal strain, Young's modulus is equal to longitudinal stress by longitudinal strain. Is where L is the original length and del L is the change in length. Young's modulus is nothing but longitudinal stress by longitudinal strain, where Y is equal to stress is nothing but force acting per unit area and the change in length by original length. Therefore, FL, capital FL by A into del L. Units for this Pascal or Newton per meter square. Here for strain there is no bulk modulus. Bulk modulus or is known as volume modulus. Not all deformations are linear. Sometimes our applied stress F by A results in decrease of volume. In such cases, there is a bulk modulus of elasticity. That is K is equal to volume stress by volume strain. That is minus F by A del V by V. Therefore, K is equal to minus PV by del V. This is known as bulk modulus. We already see that the volume modulus means the force is applied perpendicular to all the faces of the cube. That is known as bulk modulus or volume modulus. Here, if you want to find the bulk modulus means volume stress by volume strain. K is equal to minus PV by del V. The bulk modulus is negative because of decreasing volume. Since F by A is generally pressure P. Shear modulus, that is tangential modulus. A shearing stress alters only the shape of the body, leaving the volume unchanged. For example, consider equal and opposite shearing forces if acting on the cube below. Here A, the force is acting, so there will be change in the shape or size of the body. So there will be shearing force will be made as a deformed one, produces a shearing angle theta. The angle theta is the strain and the stress is given by F by A, residue modulus equal to tangential stress by shearing strain, F by A by D by DL, therefore FL by AD. This is the shearing modulus. Yeah, shearing stress alters only the shape of the body, leaving the volume unchanged. So that, for example, consider the equal and opposite shearing forces F acting on the cube below. Yeah, that is A. Then, when the force is applied, so the body will be deformed. So that there will be angle will be the angle is said to be a deformed angle. Here, the angle is said to be strain, and the stress is given by F by A. So rigidity modulus is nothing but tangential stress to the shearing strain. Is equal to tangential nothing but F by A divided by D by L. Therefore, FL by ADD, Newton per meter square. Now, in this class, we have clearly seen about the properties of matter. First, you see about the um, basic definitions and what do you mean by stress and strain, and what are the types of stress and what are the types of strain, and finally we see about the elastic modulus and different types of moduli of elasticity. In next class, we see now more deal about the torsional pendulum and the Young's model, the Young's modulus uniform bending also. Thanks for giving the opportunity to make a session effectively. Thank you once again. Thank you.